Okay. So let me share my screen. So again, this the objective of this meeting is to introduce the objectives of Sylva. So we'll cover the why are we launching this initiative, explaining the ecosystem of Sylva, but more globally the open source and telco ecosystem integration of Sylva. We can have a quick view on the adoption opportunities, giving some roadmap feedback and roadmap elements to be shared, and then have a deeper view on the architecture of the first work group concerning the cloud stack development, and finalizing, we will cover the validation center stream with Luis. Okay. And so it's an onboarding session, so don't hesitate to ask your question. The aim is also to be interactive. We have not so much slides, so the aim is really to share with you and to answer to your questions. Okay. So the facts of why we launched this initiative, really the key element is to transform the telco operator mode, where we used to have a single infrastructure per network functions, and here we want to build a common cloud layer that is supporting multi-VNF. So it's a deep transformation of the telco ecosystem that has been done in the IT 15 years ago, but on the telco ecosystem, many specific constraint requirements needs to be tackled to address this challenge. Second topic, that operators are increasingly threatened by hackers.
Guillaume,
Yeah.
sorry, Guillaume, you are not presenting right now.
Yeah, thank you.
Now you are present.
Many thanks. So it's the first slide, so it's not not too strong issue. Thanks, Luis. Many thanks. Okay. So just on the lobbying, so a new participant has joined. Can you introduce yourself? Hello. Hello. So a new joiner on the call. If you can introduce yourself.
Oh yes, I can hear.
Yeah. Yeah.
Thank you.
So you are who you are, from which company?
I'm from Huawei, and I want to know more about Sylva.
Okay.
So I attend the meeting.
This is the place. Okay. So the second pillar of this transformation is that the operators are increasingly threatened by hackers. And if you have seen, if you have watched yesterday, some dish was disturbed by a cyber attack. We do not know lots of things about this, but it's just to illustrate that this threat is more and more impacting directly the operator's activity. Okay. The third topic is that on the cloud market, we have more and more network functions that are now containerized. So we need, on the infrastructure layer, a way to host those containers. So we need a Kubernetes to host, for example, the ORAN CNF, the 5G core, the CDN now are usually delivered as a container. And last, if we want to raise the full automation to shortest the time to market, or to have slicing features, we need a full automated stack, including the cloud part. Okay, so this is why we need to develop this initiative. So the 15th November last year, we have launched at the Linux Foundation Summit with Arpit Yoshipura, the head of LF Networking and Edge. We launched this initiative with the main carriers in Europe and also with two network functions providers. Our aim is to cover the telco landscape, but also in midterm, also the edge use cases. So the projects have two main objectives. The first one is to release a cloud software framework, specifically integrating the requirement of the telco and the edge, and also to develop a validation program to support and to accelerate the onboarding of the different network functions into this stack. So the initial members are Orange, Telecom Italia, Deutsche Telekom, Telefonica, Vodafone, and Nokia and Ericsson. Those members are nowadays the board member of Sylva, and the project is hosted at the Linux Foundation. So we are launching this initiative in the European landscape, but what we really want, it's a global innovation and a global collaboration. This is why we are not limited the project to European actors, and even lots of those operators are deployment outside Europe. So it's really a global project, not limited to Europe. Okay, so just to introduce that Sylva is not the first project in this ecosystem. We have many projects, but really what we want to do is to integrate the activities and the output from the other projects, or open source project, or telco alliance. So the first telco alliance is the ORAN alliance. The objective is to develop and to promote the disaggregation of a radio access network. In this initiative, there is a dedicated work group on the infrastructure to define the O-Cloud layer. So O-Cloud layer is defined within the ORAN alliance. So concretely, in Sylva Stack, we are going to integrate the requirements of the ORAN alliance to support the ORAN use cases, so the VRAN use cases on top of this telco cloud. We need to have a strong interlock also with Anuket. So Anuket is promoting an architecture, reference architecture concerning Kubernetes to support the telco use cases. They are also promoting a framework of testing about the network functions, but also the cloud layer. So we are using this framework, and Luis can say a word in this presentation about this. And I mentioned that we were on the cloud layer, so it's so important to have a strong interlock with the CNCF, of course with Kubernetes, but we are also have a look on different initiatives. The first one is Nefio. Nefio is managing the lifecycle management of the network functions. And here in Sylva, we are managing the lifecycle management of the cloud layer. So we see a strong interlock between those two projects, but we don't know if Nefio will succeed. So we just have to look and to ensure that we've got the good interlock, but we are not limited to the Nefio ecosystem. There's also an initiative that has made lots of communication during the Mobile World Congress, which is in progress. It's a Camara who is defining and developing some API concerning the edge computing, but also the network as a service strategy with API to expose the core network capabilities. I mentioned that security is a key element in our strategy. So you've got the ENISA, which is an entity in Europe who is promoting some good practices, best practices around security, and they are also developing a certification scheme, which is EUCS. So it's a cloud certification scheme in Europe that is good best practices around security, and it will help us to have an homogeneous design across European country for a cloud layer supporting telco needs. Okay, Any question on this part? Okay.
No, it's clear.
Okay, so I will be quick on this slide. The main point is that to understand that to cover the stack, we have some key pillars. The first one is the network performance. Of course, we are mentioning network functions, so it's important to embed the telco requirements to ensure the capabilities. What is something innovative is also that we have more and more distributed needs in the telco space. The edge market, it's a very new market, and the market is not is just emerging. But what is very clear that is the telco edge market is a clear reality. So use cases like 5G core, distributed and Open RAN are requiring a distributed cloud architecture. So it's very key to have a lifecycle principle that is in line with distributed cloud. So we are going to manage bare metal automation, the capability to manage multi-Kubernetes environment. Of course, we discussed about the security design, so it will be on board on the project. The energy efficiency, I will go deeper on this topic after. And as I mentioned, we need to be interlocked with a global ecosystem, so it's important to have standardized API to be integrated with other initiatives. I mentioned Nefio before, but not limited to Nefio, of course. And relying on open source component, and also make open source our activities is a way to have a global adoption. Okay, so don't hesitate at the end of each slide to ask me a question. I continue. So this point is concerning the business opportunities. Just to mention that on the for today we have the operators, two different models, and most of the operators are mixing those models. So it's developing a cloud layer based on OpenStack, VMware, or something else to support some network functions, but also to have vendor IaaS specific solution, for example, Nokia, Ericsson, Huawei, ZTE, and others. And so here the main topic is to ensure the transformation and that Sylva can help on this transformation. So the operators can integrate Sylva to build their own operator stack. The network vendors can also integrate the Sylva stack to facilitate the integration for them to benefit from an existing open source solution. But there is definitely a room for the integrator, for the editor, or cloud service provider to integrate this stack to build their specific solution to facilitate the life of the operator. So there's a direct impact on business opportunities for integrators if they want to build their own distribution, for support and for editor to build capabilities on support functions, but also for the operator to mutualize in the future the infrastructure for the telco edge, but also for some edge services. Okay, so many partners. So here is just to mention that we started with only the operator last year. We have been joined by Nokia and Ericsson to communicate, and then we have many potential partners. So here it's just some partners who are evaluating the stack. For the moment, they have not officially joined the open source project. Some of them are already officialized. For example, SUSE, Windriver, Dell, Lenovo, Cellfocus, Huawei are already. And SixWind have already proposed some concrete collaboration on the stack, but we are working on this global ecosystem. Okay, and so there's a room for HPE, for Equinix, for Airbus. So this is why we have launched this onboarding session. Okay.
Hopefully.
This is why we are here. And so just to have a global view on the different activities that have been launched. So the telco cloud stack, Matthew Ron, who is here, will introduce this topic just after. So the aim is to develop this telco cloud stack. So when we mention developing it, in fact, integrating many existing components in the open source ecosystem. Validation Center, led by Luis Velarde. The third topic is concerning EUCS security. So Théophile, if you want to say a word, because.
Yes.
Yeah.
Hello, everyone. So the third work group is about EUCS security requirements. So what is EUCS? It's a European security certification scheme for cloud providers. So it should become, let's say, the standard certification scheme for a European cloud provider. And therefore, we Sylva, are targeting this certification scheme in order to comply with the European regulation in the future years. You may know that the regulation landscape in Europe is increasing strongly. The NIS2, so it is a Network and Information Security Directive. The second directive will be applied in 18 to 21 months. So it should be transposed in the national laws in 2024-2025. And this directive will help the member state to set some mandatory certification scheme for the essential entities of each country. And so the operators, the telecommunication operators, as they are essential entities, could be under this regulation, and therefore may be imposed a certification scheme like EUCS. This is why we want Sylva to be compliant with this certification scheme. So in this work group, we are translating the EUCS requirements to features for Sylva. So in identity and access management, in operational security, in encryption, and a lot of other security domains. And so all the deliverables are public in the GitLab.
As I mentioned, it is not limited to Europe because it's good security practices that we can enlarge globally for all the activities. Thank you. And I see also Airbus on this call. So the NIS2 is also applying for many essential entities, and there are different different level of requirement for the entity. So it's also a topic that can apply to many of the Airbus affiliates domain, for example, to illustrate. We have just launched an energy efficiency work group. So it's led by Nokia. So we are defining exactly the deliverables we want to achieve, but definitely what we know is that we want to measure the server consumption, but also, and it's more tricky to measure the CNF consumption. And then in the second step, it's not only a matter of consumption, it's also a matter of optimization of the energy consumption in terms of architecture, but also in terms of scalability. So many topics to cover in this track. Concerning communication and adoption, if we want to have a perennity in the project, it's important to have a good community, an active community, not to have too much partners, but it's important to have active partners. So we are working on this adoption framework. And so André Antunes from Selfocus, which is an integrator, is leading this work stream. And the last work stream led by Théophile so I'll let you introduce the 6 work packages, Théophile.
Yes. So the Sylva project is currently a community project under the Linux Foundation Europe, meaning it's just a technical community that is working together to build this stack, the validation program, and all of the deliverable mentioned before. The funding members are currently thinking about creating what is called a directed fund. So it's a budget structure on top of the community project in order to provide budget to for the spendings of the technical project. So this would be like the LFN structure or the CNCF structure and so on. There would be membership fees to enter this directed fund, and the sponsors of this directed fund could have some rights to decide about the spendings dedicated to the Sylva project. And this directed fund will help the Sylva project to buy licenses, maintenance of the platform, marketing, and so on. So all the spendings related to the project could be under the scope of this directed fund. So this is the work ongoing in this work stream.
Okay, so those 6 work streams are covered by the technical steering committee with the different board members who can vote for strategic decision, and the 2 co-chair are Giuseppe, who is on board, and I. Okay. Just to give a view, I mentioned that the main topic is to address the distributed cloud. So basically, a very, very high level architecture is to better understand that we can have on a central side the way to manage different CAS nodes which are on the edge side, and we are able to manage different kind of network functions. I mentioned here some network functions about distributed UPF, CDN, Open RAN, but we are not limited to this. Also IT and tooling, and we can have some central deployment or some edge deployment. Mainly on the edge deployment, you can have CAS on bare metal, but we are not limited to this. You can have even CAS on bare metal, on OpenStack or VMware, and Matthew will detail this point just after. My last point is just to mention that we've got a Sylva GitLab repo. Théophile is going to share to you the different link. So you'll have a Sylva introduction of the HLD. So you'll have all the very high level element of architecture. Matthew will present deeper information about the other repo. You've got also the validation center here, and in the governance, you'll have all the minutes of the different technical steering committee in the wiki pages. So here in Vitsim. So you have on the home page all the different meeting. And so my last word is don't hesitate to come back to Giuseppe, to me, or directly to the work group leader to mention if your entity is interested to collaborate or to have more information on specific topic. Okay. And so I let the floor to Matthew. So Matthew and Luis, you'll got 15 minutes each of one to cover your part. Okay. Is there any question before? Sorry. Is there any question? No? Okay. Thanks. Matthew, go.
Yes. Do you want me to share some slides, or do you?
Yeah, I can continue. Yeah, I can continue.
Okay.
So it's
okay. So concerning the first working group, it's really about developing the stack, maintaining the Sylva stack, and releasing the stack and putting some tag on it to have it released every 3 months. That would be the target for the moment, but it can be discussed, of course. But here we can tell you about what are the main components of the stack as it is today. So as Guillaume told you, we want to be able to deploy different kind of Kubernetes clusters. We want to maintain 2 kinds of Kubernetes clusters, the kubeadm Kubernetes clusters and RK2 Kubernetes clusters. And we want to rely on Cluster API to manage the lifecycle of those Kubernetes clusters. So I'm speaking about using Cluster API to manage both the workload clusters that are potentially deployed on remote sites, but also to manage the lifecycle of the management cluster. So Cluster API is definitely a key element in the Sylva stack as it is today, because it comes with a lot of interesting infrastructure providers that most of the operators are interested in. I mean, it comes with an OpenStack infrastructure provider, a VMware infrastructure provider, but also with a MetalCube infrastructure provider that allows us to easily deploy some Kubernetes clusters on top of bare metal. So Cluster API is one piece of the stack, one of the main pieces of the stack, but we also heavily rely on Flux, because one of the targets of the Sylva stack is also to rethink, I would say, the way we operate such an infrastructure. And we really want to adopt the GitOps approach to ease the operation related to managing the different Kubernetes cluster that are going to host the CNF in the future. So GitOps with Flux, Cluster API for the lifecycle of the Kubernetes clusters, but also RK2 mainly because it comes with a lot of hardening in terms of Kubernetes cluster deployment. And as mentioned by Théophile, the security topic is a hot topic in Sylva. So we must take this kind of requirement into account. This is one of the reasons why we want to rely on distribution such as RK2. One other element is that we are going to deploy Kubernetes clusters on top of hardened OSs. We are mainly targeting the Ubuntu OSs for the moment, but hardened version. The goal for us is to have the entire platform to pass CIS benchmarks. And we are going to use this kind of CIS benchmark scripts into a CI to really assess that the Sylva stack is secure in-house for being deployed into our infrastructures. So Flux, hardened infrastructure part, hardened Kubernetes clusters and hardened OSs, Cluster API, and a bunch of other elements that would be useful in the context of Sylva, such as the usage of Arbor to host the different CNF images and chart, OCI images, or whatever that are going to be used to deploy such CNF in workload clusters. So Arbor, we are going to integrate, we are going to first deploy Rancher in order to benefit from the proxy feature that comes with Rancher to access the different Kubernetes clusters that we are going to manage. And we also want to manage the authentication to the Rancher servers through a key cloak that will allow everybody to integrate easily external directory, Active Directory, or LDAP directories for managing users that are going to be allowed to access the Kubernetes clusters. So this is there is Vault also that is going to manage secrets, and this is main components that are going to get shipped with v0.1 version of Sylva. We still have some work in progress about some of those components, but the goal is really to be able to release this first version of Sylva before the end of March.
In the repo, you have already currently an initial version.
Yes, of course. So we can take a look at the repo as it is today, but yes, no, we are not far from the goal of this version. We just have some element to fix to be able to tag the release. So I mentioned some elements into the management cluster. Just a few elements that make Sylva more telco friendly. Those elements are mainly deployed into the workload clusters because those elements are the one needed by some CNF. We can see that we are going to allow deployment of Multus as a CNI plugin along with additional CNI in order to be able to host CNFs that need multiple interfaces. This is a first step toward a telco opinionated Kubernetes version. And this is something that is really needed by the validation center for validating the first CNFs that they are targeting. So just something, just to tell you the status, what we are able to deploy today, if you take the project as it is into Sylva, it's really we are able and we want to set up a CI for deploying RK2 and kubeadm clusters on top of Ubuntu 22.04, and with the usage of an OpenStack infrastructure. So the first version will really be about deploying the Sylva stack on top of OpenStack, but Telecom Italia is maintaining something that is not tested in the CI, but that is still very interesting and that is ready for test. They are maintaining some element to be able to deploy Sylva on top of bare metal, thanks to Metal Cube, but also on top of a VMware infrastructure. And within Sylva, and especially into the Sylva core project, we are maintaining a set of script, a set of dedicated development in order to easily deploy the Sylva stack on different infrastructures, OpenStack, bare metal, or VMware. So the entry point, if you want to get familiar with the code as it is today into Sylva, is really the Sylva core project. You will see some readmes into it in order to easily deploy the Sylva stack in your own environment, depending if you want to deploy on top of OpenStack or even if you want to deploy on top of Docker. It is something that is possible and that is maintained by the Sylva core project.
Matthew, we have a first set of questions from Nicolas. So the first one is why are we limiting to Ubuntu OS and not SUSE? So do we want to limit, or do we want to open to other OS in the future?
Yes, of course. It's not a limitation. this is what we are able to test in the CI for the moment. But actually, Sylva Core is really an element that is key for us because it's really about being able to switch any component to another one. So if you want to test a deployment of the Sylva stack on top of any other OS, Sylva Core will definitely help you doing that easily. Sylva Core is really meant to provide flexibility regarding what we want to deploy into the stack and what elements are composing the stack. So for the moment, we are releasing the Sylva stack based on Ubuntu, but this is mainly because this is what we have in CI today. We didn't test any other OS for the moment.
And the other question is why are we limiting to RK2 and not also addressing the distribution of canonical of Kubernetes? I don't remember if the distribution of Kubernetes of canonical is open source. So it's
micro-KTS is open source, I think.
Yeah.
Yes. What is interesting with RK2 is the hardening part that I mentioned. But again, flexibility is really what Sylva Core is about. So testing any other alternative would be really interesting. We are targeting RK2, but also kubeadm for the moment because kubeadm come with a cluster API. If we want to leverage such an micro-Kubernetes, let's say, if you want to test micro-Kubernetes, then the easiest way would be to leverage a micro-Kubernetes cluster API bootstrap provider. If something like this is existing, then testing micro-Kubernetes would be really easy within Sylva.
Yeah, so the aim of Sylva is not to test all the Kubernetes distribution, but what we have done is that the design is eligible to other distributions. So if there are specific needs or if we see limitation in the actual choice, we have the capabilities to integrate new solutions. Concerning the storage, maybe we can go. I don't know if we mentioned here the storage part, but it's a first roadmap. So at the beginning, we are working on the integration with Ceph, but also Longhorn. So this is the two first storage services where we can have a compatibility, because it was a new question from Nicolas.
Yes, definitely. If you deploy the stack on top of an OpenStack infrastructure or even on top of VMware infrastructure, then you can benefit from the storage that is already in place. So in OpenStack, you may probably have some Ceph storage backend. So we are using the CSI Ceph storage. And in VMware, I think it's the same. You have a dedicated connector to benefit from the storage behind your VMware infrastructure. Then the question is open regarding deployment on top of bare metal. So Longhorn is the target for the moment. Maybe there are existing alternatives I'm not sure about, but Longhorn would match our needs.
Okay. Thank you, Matthew. You're in time.
I don't know.
Yeah.
If I can speak.
Yeah, it's a question moment. Go ahead, Nicolas.
Okay. For the storage, I think the question needs to be addressed the other way. What kind of storage do you need? And then you decide what kind of storage will fit your needs. Because here in Airbus, that's the always returning question.
So we have the habit to use Ceph as a storage backend, but you need to be aware that Longhorn doesn't address all the storage solution. So if you need block storage, okay, you can go to Longhorn. And if you need a file system, you have CephFS, and for Longhorn, it's only NFS v4. So you rely on the OS under your storage solution, and there are no S3 solution.
Yes.
But
so
if you want containerized solution, you have Rookceph.
Yeah, so again, as you mentioned, it's linked to the requirements of the network functions or the IT application. So it will drive our roadmap and our priority. So this is why we are working with a group to define what are the main priority, following the main use cases we want to address, and for following also the contributions of the different members. So this is the way we can open to many other dimensions on the project. Okay, any other question? No? So I'll let the floor to Luis.
Okay, can you make me presenter so that I better present?
Yeah,
I'll
give you overall. I couldn't catch this before. Why I didn't? Yeah, you are here. Sorry. So normally it's okay for you.
Yes. No.
No, some issue. Where are you?
I cannot. No.
Yeah, I see you as a presenter. So normally it's okay.
I'm a presenter.
Yeah.
But I know. But I second. No, I don't have the option.
I will stop the sharing.
No, I don't see my.
So I stop you all and I do it again. So you're coming back, presenter.
Yes, here I am.
Okay.
I can start.
We need to do it twice.
Thank you.
Okay.
So I'm sharing some slides. Just let me know when you can see them. Can you see the slides I'm presenting?
Yes,
okay.
We can see.
Okay, good. So the thing is, what's the validation center? What's the scope of the validation center within Sylva? As we have been discussing before, Sylva is aiming to release an open source cloud software that incorporates the capabilities that are required for telco and edge workloads, as the operators have identified. So Sylva is not requirements driven, as for instance could be Anuket. Sylva is implementation driven. So we are implementing something that will be compliant using as reference the requirements from other groups, organizations, for instance, Anuket itself, for instance, ORAN and ENISA. ENISA for security, ORAN for things related to the cloud in Open RAN, and Anuket in general for the core, specifically the performance profile. So Sylva is implementing something. Since we are implementing something, we have to validate that this is that we are implementing is actually valid for the purpose. And the purpose is deploying network functions on top of it, network functions and applications, edge applications on top of it. So the validation center is not really to test the platform, because it's not the release testing for the platform. What Mathieu has just commented, there's a set of features that are being developed and they are testing them. They are testing that they work. What we are testing in the validation center is that the network functions can actually be deployed there. And actually the network functions are designed to be running or being deployed on this horizontal platform, on this agnostic platform, let's say, that is created for the telco cloud applications, but not for any specific one. So this is what we validate in the validation center, that the network functions or applications in general can be deployed on the Sylva release. It is true that while doing this, we are actually testing some of the features. We are feeding back to the other working group with things like testing the CI scripts or the deployment scripts, testing that the CNIs can be actually deployed and integrated in Sylva. But the focus is to validate the CNF. So the validation program actually has two parts. One is the CNF validation. And there's an additional thing that right now we are not focusing on that, but it will become when time comes. That is testing or validating that any commercial release or commercial product, whatever, created out of the Sylva open source is actually incorporating the expected capabilities, because Sylva is just an open source, it's not a product. Whoever who wants to create a product out of that should demonstrate that it is actually implementing the same features. So the validation program, the validation center, this working group is not to test the Sylva platform open source. It is to test that the network functions can work on top of it, feeding back to the development team, of course. And later on, we will incorporate the validation that any product created out of this open source actually incorporates the same features. So this is the thing of the validation center. It has two parts: CNF validation, which is the focus right now, and derivative stack or distribution validation, which will be in the future, probably in 6 months, once we have a first official release of Sylva issued. So the CNF validation is, as I said, is about demonstrating that network functions or applications in general can work on top of Sylva stack. I always say applications because the concept of network function, everybody relates it to the core, but Open RAN also has network functions, and edge applications are actually functionalities that will be running on top of Sylva. So demonstrating that they can work. First official validations will be done against release in version 1, the one in June, but we are already working on that and doing the first work on this and running the first cycles with some network functions. To do that, what we have to do is have a validation platform in the beginning, because, and this is what we call the reference implementation of Sylva. Once we have a Sylva release, what we will do is deploying this Sylva release, all the Sylva code, into a set of hardware, a set of servers. And this group of servers with Sylva on top of it is what we call the validation platform. We will have more than one, because, well, you just have been discussing different flavors, one with OpenStack, another with bare metal. We will have a validation platform to demonstrate network functions on top of OpenStack, another to validate network functions on top of bare metal flavor of Sylva, and whatever. So we need, of course, a reference implementation of the Sylva stack. We already have one, by the way. And something important, we call this validation and no certification purposely, because we are not certifying completely a network function. We don't think that once we validate that the network function can be deployed, this can tell any operator, okay, you are safe to deploy this in your production environment. We understand operators will run their specific additional testing. So we don't call this certification because we want to be safe there. We call it validation because it's a minimum and it's a basic functional testing after we have demonstrated that the network function is cloud native design, let's say, can be deployed in this Kubernetes kind of a platform. We will have onboarding testing, basic functional testing, some minimal performance testing or something to demonstrate that the network function is making use of the capabilities that are needed. Not all the capabilities that the platform provides are needed by all the network functions, only some of them. And probably, of course, some security-related functionality. But it's not a certification. That's an important point of this validation center. And secondly, we don't want to reinvent the wheel. So if there are some tests existing in other organizations, we can use them. For instance, we are already using CNCF test suite and the full test, and we will feedback if we identify something that could be used by those organizations, we will feed it back. So we will try to reuse whatever exists. In that part of the derivative stack, well, as I say, this is not the focus right now, but it will be in the following way. The intention of this second part of the validation center is, instead of demonstrating that the network functions can work on Sylva, it will be demonstrating that any distribution created out of the open source release includes the capabilities that are required by the different network functions. To do this, of course, we will be leveraging some of the tests that have been done when testing the release itself. And we will be using probably the validated network functions or some dummy network functions that make use or claim to require some capabilities to demonstrate that these capabilities are incorporated in this distribution and not lost when converting the open source into the commercial product. And same way, we will not be reinventing the wheel there. We will leverage some of the tests that are done by the release management testing, but also by other organizations. We will be using here Kubernetes conformance testing for Anuket, that actually is one of the tests that we are running for the release, Sylva release development. And this is not our main priority right now, because this will only happen once we have an existing, a first official release of Sylva. So our initial focus is the CNF validation. Okay, but these are the two parts of validation, apart than feeding back to the release testing, the Sylva platform release testing. So the process, and I go quick here, the process follows more or less this approach. There's two parts that can work in parallel. On the one part is testing the onboarding. So in order to test the onboarding, we need to understand what a network function needs from the platform, because I repeat, not all the network functions require the same things. Open Run network functions or functions require synchronization plugin, while core data plane core platforms require Multus plugin and not synchronization. So the first part is understanding what is needed. Second part is making the Sylva platform, once the code has been deployed on some hardware and we have a reference platform, incorporate the CNIs that are required, that actually integrate the capabilities that we have identified as required by the CNF or the application, and then perform the onboarding and confirm that the network function is properly deployed. So confirm that the network function has all the pods active, the number of pods that it needs, with the names that are needed, or whatever. And in parallel with this, we have to create a set of, or define a set of minimum functional tests, because I said before, it's not a certification, but we need to demonstrate that the application that has been onboarded actually is that application, is not something that has been onboarded. So we need to demonstrate via some application commands that it acts as it should. So I mean, an IMS or an EPC or a UPF should be acting as a UPF, so should be accepting UPF commands. A UDM should be a UDM, accepting UDM commands. So some minimal testing needs to be defined. And once we have deployed the network function or application and identify the scripts, the tests, and created the scripts, we will run this minimum function just to verify, and this will be called validation, that the network function is deployed and is actually working. If this happens, then we call it validation. But after that, any operators, before putting that in production, of course, they can do out of Sylva as many additional tests, performance tests, high availability tests, or whatever, to demonstrate the complete application in their environment. But the idea here is to demonstrate that the network function is validated, that they can be deployed on Sylva and will be functionally working. And that's all about it. Going fast in this, actually the validation process, we understand the cycle and actually this cycle can be repeated for different flavors. We may repeat it on a platform, reference platform with OpenStack and another one with bare metal. But the cycle, and probably we have to repeat it for every new release of Sylva that is issued. But the cycle will be around 5 to 6 weeks, probably less, because as we mature, the first part will be reduced probably to just 1 day. But right now it takes some time. And it has some milestones. We have a validation platform, configuration and validation platform step. That is where we prepare everything just to deploy the network function. Then after this has been configured and deployed, and as I say, this probably will be reduced because in the end, more or less all the network functions will require similar capabilities. Once the platform is ready, we will need to deploy and confirm that deployment is correct, and we will need to run the successful functional testing. Additionally, we will run new tests that we are still evolving and thinking about them in this working group, but this is basically the cycle, a 5-week cycle to validate every CNF for every release in every flavor of Sylva. We have a community area where Guillaume was presenting before, where you have all the information. There's a specific document called validation strategy that refers to everything, and that's all about it. So any comment?
Many thanks, Luis. So any questions to Luis?
Yes, question. If we want to validate the CNF on the Sylva infrastructure, do you provide the infra, or do we have to replicate the infra on our setup?
No. The program, we provide the infra. So the idea of the program, as it is defined today, we will see how we can automate it more in the future, but we are just starting. We will have a set of validation platforms. We provide the platform. We only need the validation needs a validation team. Every time we run the cycle, we need a validation team, and part of this validation team should be the responsible from the network function. And we need the image code and the Helm charts, basically. And
Okay. So this is a kind of interface contract to onboard the CNF on the infra.
Exactly.
Okay, thanks.
Okay, other questions? Okay, so many thanks to Phil, Matthew, Luis for your presentation. Luis, if you have made some little changes on your slide, if you can share to me, so I can put in the minutes of this meeting. Okay, and I will publish also the video record of this session, so you can share internally for the different company if you want to share. And so again, don't hesitate to come back to the different work group leader that were today on the bridge to have more information, or if you want to contribute. Okay.
Okay, thank you for this session.
I hope it was clear. So
yes, thank you. Long live to Sylva.
Thank you, Laurent.
Thanks. Bye. Thank you, everyone.
Bye.
Bye.
Okay.
Thank you.
Thanks. Bye.
Bye.
Thanks, everyone. Bye.
Thank you. Bye-bye.
Thank you. Bye-bye.